In the next part, we're asked to find the x-intercepts. Now, to make sure we know what those are, x-intercepts are the places where your graph crosses the x-axis. So in this case, there are two. Typically, there will be two places where a parabola crosses. Occasionally, you'll have a parabola that only crosses in one place. For example, imagine this graph were right here where it just touched right at that vertex. Then it would only have one solution. And sometimes the graphs are such that they are completely above or completely below the x-axis and they never cross. So in which case there'd be zero solutions for problems like that. So the most you can have is two solutions, and at worst it would be zero. But to figure out what these x-intercepts happen to be, we always need to take whatever our equation is and make y equal to 0. From there, we have two different options depending on the problem. We can either factor it and solve it, or use the quadratic equation to solve it. So taking our original equation here, we plug in a 0 where we used to see y. So y used to have a value, now it's just equal to 0. Then we need to factor it. And we have one-step factoring because the number in front of x squared is just a 1. There's no number written in front of x squared, so we know we can do one-step factoring. And 0 is equal to x either plus or minus something, and then x plus or minus something again. So two numbers that multiply to this n number, -3, and then add to -2. So numbers that multiply to -3 would be 1 and -3, and -1 and +3. So since we want to add to -2, it's going to be this answer right here. 1 and -3. So +1 -3. And if you were to FOIL this out, it would come out to exactly what you have above. But now the trick is to remember that your goal is to solve this equation right here. What values of x will make this equation go to 0? Well, if you want it to go to 0, either part can equal 0. So we can do it as two separate problems. 0 could equal x plus 1, or 0 could equal x minus 3. And you solve each of these problems separately. You can subtract 1 from both sides to get -1 is equal to x. You can add 3 to both sides to get x is equal to 3. And both of these are correct solutions if you recall from earlier. A shortcut for problems like this is to say take the flip of what's inside the parentheses. So to say -1 and +3. As long as x it doesn't have any numbers in front of it, that should always work. A second method for finding the x-intercepts is using the quadratic equation. Now the quadratic equation still assumes that you set y equal to 0, but then you have to find a, b, and c and plug it into this big, long, nasty equation. So since we don't have anything in front of x squared, again, we're going to say that 1 is equal to a, and then -2 is equal to b, and -3 is equal to c. So let's plug it into our equation. First thing we have is -b. So we have a negative, and then our b is -2. So -2 plus or minus the square root of b squared. So -2 again squared minus 4 times a, 1, times c, -3, all over 2a, or 2 times 1. To take this to the next step, let's clean it up. We know that -2 is equal to +2. So we have x is equal to 2 plus or minus, and then we have square root of. And if you do this little part in your calculator in one step, you're going to see that we have 4 minus 4 times 1 times negative 3, and this negative make it a plus. And so we have 4 times 1 times 3, which is 12. And 4 plus 12 is equal to 16. So we clean that up to square root of 16. And that's all over 2 times 1, which is 2. Going on, the square root of 16 not only cleans up nicely, it cleans up exactly to the number 4. So 2 plus or minus 4 over 2. At this point, we can simplify every single term in this problem, all 3 independent terms. Or if we wanted to factor things out, we could do that. But I'm going to take from every single one of the 3 terms here. So there's a 2 on top, which becomes a 1, 2 on bottom, which becomes a 1, and a 4, which becomes a 2. If you're ever going to do canceling like this, you always have to make sure you take from every single term, all 3 of them in this case. So that's equal to 1 plus or minus 2 over 1. So basically 1 plus or minus 2. Now 1 plus 2 is 3, positive 3. And on the other side, 1 minus 2 is negative 1. So those are our 2 roots, our 2 x-intercepts. And we can get that using 2 different methods. In this case, we use quadratic equation. Over here, we use factoring. We got the same answer. The times where you would use factoring is when you have small numbers like this, and it's very easy to go in one step to your factored answer. If you have anything in front of x squared, or some of these numbers are pretty big and intimidating, I would stay away from factoring and always use quadratic equation. Another situation is if you try to factor and it doesn't work. There are many problems that cannot be factored. You can use quadratic equation because it will work under all circumstances with all numbers. So that's always one thing that you can try.